Example 3 is a question from the 2014 AP exam, and it says consider the differential equation dy by dx is equal to 3 minus y cos x, and then y equals f of x be a particular solution to the differential equation with initial condition 0, 1. So the y graph passes through 0 and 1. And f is defined for all real numbers. So part A says a portion of the slope field is given and select the solution curve that passes through point 0, 1. So if I take a look at my slope field here, I'm going to find point 0, 1. So 0, 1 is that coordinate right there. And to draw the particular solution, I'm just going to sketch it. And I'm just going to look at the slope lines and just follow where the slope lines are pointing. And I can see that if I follow the lines, it looks like it's going to follow this general pattern this way. It's pointing down here, so it looks like it's pointing to that section. Okay, every time I hit a section, I take a look at that slope to see where it's pointing next. And it looks like if I follow the slope lines, it's looking like it's going to give me a solution that maybe looks something like that. Okay, so this solution is going to be the one that passes through the 0, 1 coordinate. Okay, so when asked to sketch it, that's all we're doing. We're just going to sketch that diagram and sketch that line by following the slope field lines. Part B says, write an equation for the tangent at that point 0, 1 and use that tangent line to approximate f of point 2. So f of point 2 is just to the right of that dot. What we want is we want to come up with an equation of the tangent line. So equation of this line here. I'll draw that again. Do a little bit better job of drawing that. Okay, maybe something that looks something like that. Okay, so it's passing through that point, and we're going to use this line to approximate the coordinate that is just to the right of that dot. Okay, so to find the equation of this line, I need a slope and a point to put it into the point slope form. So I need an x and y coordinate. So the x and y that's been given is a point of tangency. So that's going to be our 0, 1 point. So x is 0, y is 1. What I need is slope. To find slope, I use the differential equation. So using the differential equation, this will allow me to calculate slope. So my slope value, which I'm going to call m, is going to be calculated by the dy by the dx function at x is 0, y is 1. That's the point of tangency. When I plug that in, I'm going to end up with 3 minus 1, which is 2. The cosine of x, which is 0. So 2 times cosine 0 is 1. That gives me a slope of 2. So in my equation then, that m value is going to be 2. So writing my linear equation is going to be y equals the slope of 2 x minus 0 plus 1, and that is the equation of the tangent line in the point slope form. Now what we're going to say then is that if we want to find the point on the red graph, which we're going to call f, so f of point 2, the graph at point 2, is going to be approximated by the green line. So if I want a coordinate on the red line, I can say since point 2 is close enough to the 0 tangent point, the x is 0 tangent point, I'm going to say that will approximate the y value on the red graph. So when I plug in point 2 into this equation, I'm going to get a y value of 1.4. So that's going to be, somewhere around here. Okay, the coordinate that we're actually looking for is on the red line, so it's just a little bit below, and we can tell by the curvature that that's going to be below. So the approximation of 0.2 is approximately 1.4 using that tangent line. So part C says find the particular solution that passes through 0 and 1. So basically what we're being asked to do is solve the differential equation. To solve this differential equation, we're going to separate the variables. So this is part C. We're going to separate the y's with dy, and we're going to put the x's with dx's. So we're going to end up with cos x dx. We're going to integrate both sides of that equation. On the left side, we're going to end up with a log function. Because there's a negative on the y, we have to account for that negative by dividing by -1. The antiderivative of cosine is going to be sine, and then we have to make sure we have a plus c. So I'm just going to, I don't like that extra negative, so I don't like it with the log, so instead of putting into the log, I'm just going to put it to the other side, and I'm going to call this c2 minus sine x, and I'm going to solve for c2 instead of solving for the original c. So to solve for that c, I'm going to plug in my coordinate. So in this case here, I'm going to plug in my initial condition of 0 and 1. So y is 0, x is 0, sorry, y is 1, and x is 0. So when I plug that in, I get log 3 minus 1 is equal to the c that I'm solving for minus sine of 0. So then sine 0 is 0, log of 3 minus 1 is 2, so log 2 is the value of c2. So now I could solve for that c2 here. I could have also have put it in the exponential form and solve for c2, because what we'll end up seeing is when I put it in the exponential form, so before I do that, so I end up with log 2 minus sine x. So when I put it into the exponential form, so I'm going to do that up here, I end up with 3 minus y is equal to e log 2 minus sine x. And we can split that log 2 off, and that ends up being the coefficient on the e function. So we end up with 3 minus y equals, I'm just going to highlight this here. So that log 2 is going to become e to the log 2, which is an identity, that's equal to 2, times e to the negative sine x. Okay, and then rearranging this, I'm going to end up with 3 minus 2 e to the negative sine x. Okay, I moved that over to the other side of the equation. I put the y on the right-hand side, and there's the specific solution to this differential equation. And this one passes through, this one will pass through the point 0, 1.